Good evening to all. Today I have taken another interesting topic which is for radial loads acting on bearing. So let's understand how the radial load is calculated. Why it is important? Because for see this general bearing criteria and thrust bearing criteria, we need to find the specific load and verify whether this is less than the allowable limit. That is why it is very important to find the radial load for the general bearing and axial load for the thrust bearing. So in this video we are going to take up only radial loads. These are the radial loads: load due to mass of shaft, mass of impeller, mass of coupling and gear transmission, and this is axial loads. So in this video we are going to consider only the radial load because of mass of shaft, mass of impeller, mass of coupling with the various configurations and various location. Let's understand what is reaction force and what is the load acting on the bearing. So if you look at this, this is shaft supported bearing A and bearing B. W is a load acting on the bearing and RA is the reaction force on the shaft acted by the bearing. So magnitude are same but opposite in the direction. So if the reaction force is upward, the load on bearing will be downwards, and but magnitude will be same. So we have to first calculate the reaction forces on the shaft at bearing location A and B, and the same will be used as a the load on bearing at A and B. So radial force due to mass of the shaft. So let's consider mass of shaft which is uniformly distributed and it is resting between bearing A and bearing B. Center distance between bearing is C, and this is distance C1 from A and C2 from B. So mass of shaft is ms kg and weight of shaft will be ms into g, which is Newton. Taking the bending moment with respect to bearing B and clockwise is positive, and Ra into C minus ms into g into C2 is 0. So Ra is equal to ms into g into C2 by C, but C2 is equal to C by 2. So Ra is equal to ms into g upon 2. So similarly, we can calculate the reaction force at bearing B by taking bending moment from with respect to A. So where you can see RB is equal to ms into g by 2. Now another case, the radial load due to the external mass in between the shaft. So ms is external mass which is acting in between the shaft. Ra and Rb is two bearing location, center distance is C, and location of mass from bearing A is C1 and from B is C2. Bearing B is from C2. So external mass is mc in kg, external mass, weight of external mass is mc into g into Newton. So taking again bending moment from the with respect to bearing B and clockwise is positive, we can say Ra into C, and this is mc into g into C2 is anti-clockwise direction, so minus is equal to 0. So Ra is equal to mc into g into C2 by C. Similar calculation shows for Rb is equal to mc into g into C1 divided by C. When a special case C1 is equal to C2, then Ra is equal to mc into g into C by 2 and Rb is equal to mc into g into C by 2. Now this is the third case where overhung radial load due to overhung mass on the shaft. So Ma and Mb are two masses which is attached on overhung side, and Ma is attached from distance A from the bearing A, and Mb is from distance B from the bearing B. So left side mass is Ma kg, left side weight is Ma into g, right side mass is Mb kg, right side weight is Mb into g Newton. Again taking the bending moment from bearing B with clockwise positive, so Ra into C is a positive, but this is usually negative, so mc into g into A plus C is a negative. But this is positive, so we can say mb into g into B is positive, is 0, total will be 0. So Ra is equal to bracket start ma into g into A plus C bracket close minus mb into g into B divided by C. Similar calculation shows Rb is equal to mb into g into B plus C minus ma into g into A bracket close upon C. So these are the reaction forces due to overhung shaft. Now let's calculate the reaction of considering all three types of loads. So reaction force On the shaft at bearing A, RA is equal to ms into G by 2. This is because of shaft of the weight, plus MC into C2 into G by C. This is because of external force, external mass attached in between the shaft, plus MA into G into A plus C minus MB into G into B, bracket close, divided by C. This is because of MA and M2 overhung shaft. Similarly, reaction forces at bearing B will be RB into MS into G by 2. This is again because of mass of shaft, plus MC into G into C1 by C is because of internal between the external mass in between the shaft, and MB into G into C B plus C minus MA into G into A upon C because of overhang shaft. So radial force on bearing A in downward direction is equal to reaction force on shaft A in upward direction. So same magnitude, opposite direction. Radial force on bearing B is downward direction is equal to reaction force on shaft B, as shaft at B is upward direction. So this is how we can calculate the radial force at bearing A and bearing B, same magnitude, opposite direction, that is in downward direction. If R1, RA and RB are positive, so this will be upward, so reaction force is upward, so bearing on load in downward, and then we can calculate the specific load. So thank you. I hope you have enjoyed the session. Thank you for watching.